In this video, we're going to discuss how to find a stationary point of a given curve, and we're told that the curve is y equals to cos cubed x root sin x, and it's given that the curve has one stationary point within this given range in the interval 0 all the way to a half pi. Then we're supposed to find the value of x, or the x coordinate rather, at this particular stationary point. So we're going to have a step-by-step process on how to go about that. And if you're new to Proflan YouTube channel, consider subscribing so that anytime we're going to upload further tutorials, you'll be notified. So our answer should be given correct to 3 significant figures, and you are going to earn 3 marks after working out that particular question. This is a P3 question, exam question that was done, so that we can be able to get to prepare well on how to perform differentiation question. If you look at y equals to cos cubed x root sin x, this is a question you can be able to differentiate using a technique known as product rule, and also at some part and at a given point you will be required to use chain rule in order to simplify this. So in our solution part of it, we are going to start by writing the equation the way it was given, y equals to cos cubed x root sin x. So we can be able to identify, in order to use product rule, we're going to identify what is our u and what's our v. So this is going to be, actually this is going to be our u, and this other part is going to be our v. So in the process of preparing to use product rule, I need to prepare the ground. Because we know how product rule states, then we need to find the u and the v, so that when we just write product rule, we're going to go straight and work it out. So in this case, we know our u is equivalent to cos cubed x, then we need to find the u dx, and our v equals to root sin x. We need to find also the v dx, so that we're going to, once we have that, we can now write product rule and then we plug in those values. So we start with du dx. Du dx is going to be, now you see that power there, we are going to use power rule. Actually, to differentiate cos cubed x, you are going to use chain rule. So the first thing and the first function we shall look at is the power 3. So we are going to use power rule to differentiate this, and we shall take 3, and now power 3 is going to reduce by 1, and this is going to become cos squared x. Then we multiply that answer that we have by the differential of cos x. Now you don't look at the power, you look at now the function cos x. If you differentiate cos x, you're going to get negative sin x. Now we have applied chain rule at this point. So the first thing, you look at those functions independently. You differentiate cos power 3. Now power 3 will become 3 cos squared x. Then now you go into the function cos itself, you differentiate it, you get negative sin x. So the final answer here become, actually, let me adjust this, so it becomes negative 3 sin x cos squared x, cos squared x. So this is du dx. Moving to the v dx, also we're going to use chain rule. We can be able to write actually this as if you differentiate this, you are going to get a half sine raised to power negative a half. Then we differentiate that particular function. Okay, all right, we can be able to write v equals to root sin x in the form of power a half. So this is going to be sine raised to power a half, so that we can now use power rule in order to differentiate sine x raised to power half. So we can now take the power down and then write sine the way it is, reduce the power by 1, and that's going to be negative a half. Then again, we need to differentiate the inner function without looking at the power, and that becomes cos x. So this is going to reduce to over root sine x. So we have dv and also we have du. The next thing that we are going to do now is to write product rule. Now, if you write product rule, actually dy dx is going to be given by the formula, that is product rule. All right, let us just write it here now. We have using product rule, we can be able to write this as dy dx equals to u dv dx, right? U dv dx plus v du dx. Then now we need to substitute, because we know u is actually cos cubed x, and we have our dv dx here, which is cos x over 2 root sine x, right, the way it is. Yeah, that's why now our work is now cleaner, because we had prepared the ground so that we can do our farming properly, because we knew that in this product rule we need dv dx, in this product rule we need du dx. We have already found it. Now we are just plugging them in so that our work can be well organized. There we have v du dx, and our du dx is actually this part that we have du dx, and already we have it here, so that now we can simplify that expression, and this expression is going to simplify to cos cubed x cos x over 2 sine root over sine x, and this is going to become what? This is going to become sine x root sine x cos squared x. Now we have the gradient function of y equals to cos cubed x root sine x. We need to remember that at the stationary point, at the turning point, at the stationary point, dy dx is always equals to 0. So meaning this gradient function that we had gotten here is the one that we're going now to equate to 0. So we're going to write the function the way it was, and then minus 3 sine x root sine x cos cubed x should be equal to 0. Then we multiply all through. We need to get rid of the fraction. We are going to multiply all through by 2 root sine x. And then if we multiply like that, you can see this particular part here multiplied here also. This term and this will cancel out, so that we can have our function reducing to this. Now, what you need to remember is that we can now factor cos squared. We can factor cos squared x out, so that we can now remain with this is actually cos x cos squared x, yes, minus 6 sine squared x. So we have this equation, which will mean that cos squared x will be equal to 0, or cos squared x minus sine squared x, 6 sine squared x, is actually also equals to 0. So from the first part, which is cos squared x, if you find the square root both sides, you are going to remain with cos theta equals to 0, and actually this should be x. Don't know why I'm writing cos theta. So if you find the cos inverse both sides, you're going to get a half pi, and actually this is out of the range. It's out of the range, because if you can look at the range that was given at this particular point, it was x should be greater than 0 or less than half pi. So since that's out of the range, we are not going to actually use that value of x. It should be x not theta. Now this one also we are going to say is equal to 0, so we can write in the same trigonometric ratio, because we can now change sine squared x to cos, and that's going to be cos squared x minus 6 into bracket 1 minus cos squared x equals to 0. And we can now simplify this so that we can say get 7 cos squared x minus 6 is equal to 0. If you take 6 on the other side and divide by 7 both sides, we're going to have cos squared x equals to 6 over 7. Then we find the square root both sides, and we're going to have cos x equals to root 6 over 7, which will mean that x is going to be equal to the cos inverse of this particular part that we have here. Now, I've always mentioned and opined in this channel that anytime you are solving and you're finding different values of x here, it will mean that you need first to pause. You pause and know where are you finding the values of x, where cos is positive. So cos is positive in the first quadrant and in the fourth quadrant. So, which means that we're going to say this is a cos inverse of that. We get the principal angle. Let us just draw that quadrant first. So this circle here, we identify the first quadrant and the second quadrant, the fourth quadrant. So if we find these angles and we find them here, so it means the angle is going to lie in the fourth quadrant or in the first quadrant as shown there. So if we find now, if we find the cos inverse of root 6 over 7, we are going to get that as actually 0.388 radians. So this angle is going to lie here or down. So which means at that given point, that's the only value for x, because if you find other values are going to be out of the range. If you have gotten value from this particular video, consider subscribing so that anytime we're going to upload future tutorials, you'll be notified. So we've come to the end of that particular discussion.